The subject is cell, the EMF and the internal resistance. Let us understand what is a cell. Cell is a battery, electrical battery. You have heard of. Electrical battery is a electrochemical cell. It is an electrochemical cell. What is meant by electrochemical cell? Chemical reactions accompanying electric current. Chemical reactions accompanying electric current. So electric current and chemical reactions both are involved in it. There are two types of cells. Those cells are electrovoltaic cells or electrogalvanic cells, where electric energy is produced by the chemical reaction. So it is a source of electric current. Electric energy, it is produced by the chemical change or chemical reaction. When the chemical reaction takes place, electric energy is not produced or generated. It is a source of electric current. And other type is electrolytic cell. Electrolytic cell. It is the one when the current is affected, chemical reaction takes place. That chemical reaction takes place by the effect of electric current. That is, it consumes electric current or electric energy during the reaction. So it is just these electrochemical cells is a phenomena in which is an interconversion of two different types of energy, electric energy and chemical energy. In electrovoltaic cell, chemical energy change into electric energy. But in electrolytic cell, electric energy change into chemical energy. That is the difference. So let me talk about in details about the cell and the reaction. So this is the one I written as a genial cell. So in this I will give a description about the cell. It means a zinc rod, a zinc metal is dipped in the solution, electrolytic solution. There is a zinc solution containing zinc ion. Zinc ion. Zinc rod is dipped in a solution of zinc ion. That is one compartment. In the other compartment, the copper rod is dipped in the solution of copper ion. These two electrolytes are connected by another electrolyte, that is one salt bridge. The suitable one is ACl for this one, potassium chloride. So when this zinc is dipped in the zinc solution, what happens? Some of the zinc, that is atoms in the zinc metal, some atoms of zinc ionizes. I see that becomes zinc ion. That is dissolution. That zinc metal dissolves. What is the dissolution here? Zinc atom becomes zinc ion and leaving electrons on the metal. That is electron rich minus. And that zinc will go into as a zinc ion. That is a dissolution of zinc in zinc solution. As a result of this electric potential is developed on this metal. There is a negative potential, electron rich. That is spontaneous. At the same time, you see that some of the copper ions get deposited. Here deposited by losing electrons. Copper ions into copper atom. Sorry, by gaining electrons here. Copper ions gain electrons from this metal and deposit as copper atom or copper metal. And as a result of which electron deficient. This metal losing electrons and giving to copper ions, that is positive electropositive. So this is called potential. This is a potential, positive potential, negative potential. It is spontaneous. So when you give the connection between these two by a conductor, that is an electronic conductor. Only electron can flow. Electronic conductor is a metal wire. So now can you tell what is the direction of electron flow? Here electron rich, electron deficient. Naturally, electron flow from electron rich to electron deficient through electronic conductor. So this flow of electron causes electric current. You know the direction of electric current in the reverse direction. That is a electric current. This is the direction of electric current. If this is the direction of electrons, direction of electric current in the reverse direction by convention. So the conduction by electrons, it is electronic conductor. And here also there should be a conduction, that is for a circuit, one circuit. So here from this compartment to this compartment, here in between what is that? There should be what is that? Ions pass or migrate. Electric current, here ions are migrating, positive ions. So in this case, negative ions are migrating towards this solution and positive ions are migrating this solution to make up for what is that? Loss of this copper ion and excess of zinc ions, negative ions. So these ions are migrating, positive, negative ions this side, positive ions this side. Migration. Ions are migrating. Ions are what is that? Passing through the solution. So this passing of that is ions also cause, that is charged ions. No, ions are charged particles. The flow of those charges will also cause electric current, flow of current. So the direction of electric current in the solution is here, from here to here. This is the direction of electric current. Like this. So when you what is that? You have two compartments. When you give the connection like this, these two by electronic conductor and this solution by electrolytic conductor. Electrolyte by electrolytic conductor only. The reaction takes place by itself, spontaneous reaction. Reaction occurs by itself. That is dissolution of zinc on the zinc electrons here. And the copper ions in the solution getting deposited, reduce on the copper metal. The overall reaction is this overall reaction. Zinc is dissolving, copper is depositing. Spontaneous reaction. Reaction occurs by itself. So while the reaction is taking place, electric current is flowing in this direction. This is the electric current flows in the circuit. As you know, as electric current flows, there is a loss of current due to resistance. This is called external resistance. External resistance. And what is meant by EMF? I will tell you later. First, spontaneous reaction. Is it not? Now the same reaction, what is that? It can be reversed. That is, if you apply the potential, electric potential in the opposite direction, potential difference exactly opposite of this, external potential more than this potential, external potential. So some source of battery outside, when that electric energy or potential is applied on this in the reverse fashion, the reaction reverses. What is the reaction? Reaction, this is what is that? This is a reaction, spontaneous reaction produces electric current. When you apply electric current in the opposite direction, that is current direction reverses. This reaction, current becomes this is the reverse direction. It happens, this reaction takes place. This is exactly the reverse of this. Zinc deposit on the zinc metal, copper dissolves into copper ions. This reaction does not take place, doesn't take place by itself. It is a non-spontaneous. It can take place from the external, by external energy. You have to give external force, external energy to affect this reaction, non-spontaneous. So in this case, electric energy is consumed, reverse. Here electric energy is produced. Here, sir, look at this reaction is a reversible. Forward reaction, backward reaction. Forward reaction is spontaneous, backward reaction is reversible. So it is, what is that? Forward reaction. What is forward reaction? Gives energy, electric energy. Electric energy is getting exhausted. Electric energy content is decreasing, giving energy. It is discharged of battery. When the battery is using, it is getting discharged by using electric power. After the electric power is exhausted, when you apply potential, it is charging of battery. So reverse reaction takes place. That what the chemical energy lost, regained by absorbing electric energy. So back reaction takes place. Again go back to the same initial state. Electric energy is stored up in the reverse direction. That is called as charging. So you see the battery discharged when it is used. After the electric power is exhausted, we have to charge it again to restore that electric energy. So that is the purpose of the cell or batteries. So this is one type of cell. It is called Daniel cell. There are many cells you have seen that in our, what is that, daily usage. One is lead acid accumulator. That is the batteries you are using in automobiles. That is automobile. What is that? In vehicles, batteries. Petrol car or diesel car, you have big batteries. Lead acid accumulator, where lead is an anode. In that case, a sulfuric acid is an electrolyte. I do not go in detail. Lead dissolves while it is giving energy. While charging, lead gets deposited. That is a charging and discharging. So these are the batteries you have seen in the automobiles, whether the vehicle is big or small. Petrol vehicles and diesel vehicles, they have one battery for the functioning of that. What is that engine? The electric current is required for in that cases, or in also lighting purpose. And most important one is, that is present day, the battery. What is the battery using? Lithium ion battery. Look at that, today we are depending on this lithium ion battery. After the discovery of this battery, cost of lithium has gone very high. What is a lithium ion battery? You have seen in all mobiles the batteries is a lithium ion battery. Laptops, the batteries, lithium ion batteries. So in many electronic gadgets, the batteries, what is that, chargeable and dischargeable batteries. Here lithium ion battery, you are using. Not only that, now we are in most advanced state. Lithium ion battery is also in electric vehicles, cars, buses and train. That is the one why this lithium ion battery. So same type of principle is involved, but only thing is lithium ion battery we can have a very compact make. What is compact? Highly compact make with a small, that is at very high electric current. High density of electric current can be stored in a small volume. That is the one we design using lithium ion battery. So that is the advantage. High content of electric energy can be stored in a small material, that is a cell like this, and most efficient, and that too easily, what is that, dischargeable and chargeable. That is most important. That is the one you are looking at. So what is lithium ion battery? Here the anode is lithium deposited on the copper. That is graphite on which lithium is deposited, anode, and the cathode is some transition metal, cobalt oxide, containing lithium, of course. That is cobalt oxide is the cathode. And what is electrolyte? Electrolyte is some different. Electrolyte is what is that? Lithium, that is fluorophosphate. Lithium, that is fluorophosphate of lithium. That is a salt using, and that salt, what is that, is dissolved in not water, it is an organic solvent. What is organic solvent? Ethylene carbonate. Ethylene carbonate, that is highly polar. Because of high polarity, high solubility, that is the one we require for that. That salt should be dissolved in a solvent which high solubility. Why you are using lithium fluorophosphate electrolyte? Because through that electrolyte, lithium ion can migrate at faster rate. Ionic mobility, lithium ion mobility is very high in that electrolyte solution. So you can use both as liquid as well as what is a gel type electrolyte. Gel means we can make this jelly like that. So that electrolyte and the solvent is, there should be a salt and solvent. Here also water and that is a zinc salt like this. So in that case, what is that? One electrolyte between the two electrodes, and electrolyte is, that is lithium fluorophosphate dissolved in ethylene carbonate, organic solvent. The very, that is that suitable. So this lithium ion battery is discovered in 1985. It got the Nobel Prize. Lithium ion battery, because of that efficiency and high energy storage. In 1991, it came into a practical purpose. Then what is that? Mobiles, laptop. The industry is revolutionizing. There is electronic industry. And also today in the electric vehicles, there is lithium ion battery vehicles are using. Charging and discharging. Here what is that? Lithium dissolves while giving energy. Lithium dissolves, migrate towards this and absorbed by this cobalt oxide as a lithium cobalt oxide, migrate through the electrolyte. During discharge while giving energy, this is the one. And during what is the charging, reverse reaction, lithium deposited here now in the form of lithium cobalt will dissolve and go back and deposit. It will regain what is the initial state, lithium. That is charging. There is a principle involved in. I don't go into detail about this. That is just to know that what type of batteries are using. The most important battery now you are using lithium ion battery. Lithium ion act as what is that? Electron source. as a very good electrolyte. It's itself migrate through that electrolyte. Okay. And also what is that? That battery, that is usage, efficiency and the life. We also look at the life of the battery. Long term use. All because of this benefits or beneficial effects. Using lithium ion battery is the one suitable in all such electronic gadgets and motor vehicles. So this about the cell. Now about the EMF. What is EMF? EMF means electromotive force. Meaning here I said when this electrode is dipped in this electrode in this dip, electrode is dipped in the solution like this and without a connection like this. This develops a potential. Some of the copper ions are deposited and attains positive potential. And some zinc ions dissolve in it and attains negative ions. This is negative potential, this is positive potential. By itself, some negative charges are accumulated, positive charges are accumulated, negative charges are accumulated. These are potentials. So that is positive. The difference between these two potentials is what is that? Electromotive force. That is electric energy, electric potential energy, that is given as EMF symbol epsilon. What is the amount of potential this battery can produce depends on what is the difference in potential between these two. It is positive potential, it is negative potential. Difference is minus. So minus into minus becomes plus. So sum of this potential is the EMF of the cell. So without having this connection and this connection, whatever the amount of potential it is developed, potential developed, we can able to develop. The difference in potential is EMF of the cell. When you give the connection, electric current flows. The electric current, what is that? Decrease the EMF. What is the potential energy? The potential difference decreases. It is because of electric current. As you know, here there is also electric current is flowing. Electric current is flowing through this electron, the solution, electrolyte solution. The electric current is flowing through the metal wire, like this. So whatever may be the material, the solution, liquid or solid, when the electric current is flowing, it has what is the property by virtue of nature exhibit what is restriction, electrical restriction or electric resistance. So this solution also electric resistance. So this electric resistance is called as R. It is known as internal resistance. Why it is called as internal resistance? Inside the cell, here this is cell no. Is the electrolyte no? Inside the cell, the resistance inside the cell, that is resistance. And I into R, what is that? The potential energy or potential difference. Why the potential difference? This potential is consumed some amount of electric energy minus. Why? This electric, without flowing of this electric current, this flow of electric current consumes some amount of potential, some amount of what is inside. So that is current into IR, according to Ohm's law, V is equal to IR. So this current is flowing I into R is the potential or potential energy. It is because of internal resistance minus IR. So minus this gives what is the net amount of. So what is the net potential at this? It is a V is equal to epsilon minus IR. Remember, this equation is very important for all cells of battery. So what is V? Electric potential difference between these two, which can be applied to other any external any external circuit for a consumption of power. So that the resistor means it is meant for consumption of power. So the amount of what is that potential difference which is developed, which can be applied on external electric circuit, it is equal to this minus this. That is the EMF of the cell, and this is the IR. I is the current flowing in the circuit, and R is the internal resistance. Remember about the cell is this. About the EMF is this. About the internal resistance, R is the internal resistance. Resistance exhibited by the electrolytic solution where the current is flowing. So this is what is that. So when you apply this, what is that potential to this? As usual, what is that? That is Ohm's law. B is equal to IR. So I mix this current into this resistance. So we can see what is the I for this. Solve for I using the equation. I is equal to epsilon divided by R plus R. When you put R equals 0, that is resistance equals 0. So you are about to use the power. What is the maximum current which, that is I is equal to reduced voltage. When R equals 0, I is equal to epsilon by small r. Epsilon by small r. What is it I? It is the current, electric current, maximum electric current. We can draw or we can obtain from the cell at the initial state. Maximum, that is the one we are looking at. When you design any battery, that is like Daniel cell or acid accumulator or lithium ion battery, what is the maximum current we can able to get? That is the one decide. The battery power. That is why this equation I solved it for. So here the equation the maximum current, that is the ratio. It depends on what is that? What amount of EMF the cell can have. Divide by into. So if you reduce the internal resistance as much as possible, because of that particular what is that lithium ion battery, that electrolyte system, very less electrical resistance, and this also very high EMF in that lithium ion battery. Both are what is that saying that maximum current can be drawn from lithium ion battery. Not only that, with all this chemical and combination, what is that the life and the function, that is discharge and charging, also most efficient. That is why lithium ion battery is the one today we are using. So this is about what is that cell EMF and internal resistance. Next the concept is, so when you look at that, when you have conductor like this is a electrical conductor. This electrical conductor has two resistors, that is two resistances, where two resistances combined in series. Look at that. And this conductor, look at the same thing, but there are two resistors, but the combination is parallel, that is they are arranged in parallel fashion. Here in series one after the other, but in parallel connection like this. So in this conductor, let us look for what is the effective resistance, total resistance of this and total resistance of this in the conductor. I will tell you later how you get it. Same thing. Instead of taking resistors, you are taking cells like this, electrochemical cells. So there are two cells now in series, connected in series in the conductor. Here the two cells are connected in a parallel fashion like this. The same thing. Cells are in parallel, cells are in series. Let us see what is the effective here. Resistance is internal resistance. What is the effective or total internal resistance combination and total resistance due to this combination. That is the one. And one more. What is the effective EMF? Total EMF by this combination and total EMF by this combination. That is what we are looking for. This mathematics are derived for that purpose. So let us go into that. What is the effective resistance by this combination? If this is a conductor, between A and B, the potential difference between this point and this point is, let us say, B. There is always a potential difference for a flow of electric current. So what is the potential difference between this point and this point? What is the amount of current is flowing in the conductor? I. If that is the case, what happens? Here the same current flowing through this as well as this, from this end to this. No change in current. Amount of current remains same. What about the potential? Let's say potential at this point. Potential at this point. Potential across this resistor. Potential across this resistor. What is also called potential drop or power consumption in the form of potential. It is not same as V. It is different. If you say it is V1, it is V2. If R1 is a resistance of this resistor, R2 is a resistance of this resistor, then this equation is applicable for the series. What is V? Total potential between these 2 points is V1 plus V2. V1 plus V2. So whatever the total potential applied here, some potential drop is at the total pressure. Some other potential drop here, consumption here, V1 plus V2. So in this equation, what is that? Using what is that Ohm's law? Correct? What is that? What is Ohm's law? V is equal to IR, V1 is equal to, accordingly calculate this. So V1 is equal to, current remains same, or resistance. Potential is this for this resistor. For this resistor, this is the one, V2 is equal to IR2. And the total V IR, that is total potential electric current, this R, that is that resistance. So this is called effective resistance. So this total resistance. So V, this V is equal to IRE, this V1 is equal to this, V2 is equal to this. V is equal to IR. And simplify I, take out I common factor, cancel. That's right. Remaining is RE is equal to R1 plus RT, R2. That means effective resistance, total resistance of this combination is sum of the resistances R1, R2. If there are many resistors like this, 1, 2, 3 and M number, what is the total resistance in this conductor or effective resistance? Just sum them up. Sum of all the resistance. That is for a series. Now let us look for in the parallel connection. What are you looking for? So this is for a series connection. V is equal to V1 plus V2. But in parallel connection, V remains same. Whatever the potential applied between these 2 points remains as the same potential across this resistance and the same potential across this resistance. V is the potential, the same potential here, same potential. What difference we see? Difference is what is not I. The total current flowing through this is I. I is equal to I1 plus I2. What is this? Kirchhoff's first law. What is Kirchhoff's first law? A junction like this. The total current entering this junction is same as the total current leaving the junction. This current is entering, these two currents are leaving. There is only one conductor for the entry, there are two conductors for the leaving. So this current will never be same both, it will be divided. Amount of current will be divided to two conductors, two different amount of currents, I1 plus I2. If there are three conductors, I1 plus I2 plus three different currents dividing. This is called Kirchhoff's first law. So accordingly, what is that? Total amount of current up to this point is this current plus this current. This is the one equation applicable for this. If that is the case, then you what is that using Ohm's law, apply this. Find out what is I, what is I2, what is I2 using Ohm's law. That is V is equal to IR and I is equal to V by R. What is I1? Look at that, the potential remains same, resistance is R1 but the current flowing through this resistor is I1. So I1 is equal to V by R1 about this resistors. About this resistor, I2 current is equal to V by R2. Substitute into this equation. There is a total current, the total effect V by, what is the total? That is resistance. Total resistance is RE, effective resistance. The potential remains same across these 2 points, across this resistance, this potential remains same. V by RE. Simplify, VV gets cancelled, remaining is 1 over RE, this is 1 over RE, 1 over R1, R2. What is effective resistance of this combination? Total resistance of this combination is, there is one. Reciprocal of the total resistance is equal to sum of the reciprocals of the resistances. If there are many resistors like this is the one applicable. What is that? Yeah. So 1 over the effective resistance is equal to whatever the number of resistance in parallel. Here n number of resistors in parallel. That is plus reciprocal of R plus. That is the effective resistance. So if there are only two resistances, we can have this formula as well as. Simplify this taking LCM. R2 plus R1 or R1 plus R2. It is same as. Take the inverse of this. What is RE? This becomes inverse. R1 into R2 divided by R1 plus R2. So reciprocal, what is that? Effective resistance, if there are only two resistances in a parallel, product of them is divided by sum of them. For many, this is one. That is for resistors in the conductors in series and parallel. Let us apply the same concept to cells in series and parallel. If the cells are what is that, two different cells, as you know, if this cell has EMF epsilon 1 and as you know the potential difference between these two is V. This is the potential difference. Here we see that different potential at these cells. Here V1 is a potential, V2 is a potential. The same equation of the total potential at this point is equal to sum of the potentials V1 plus V2. And these are EMF of the cell. It is R1 internal resistance EMF, R2 internal resistance EMF. Current remains same all over going through this I. Now you have to calculate what is the V1 and V2 using not by what is that Ohm's law, using this equation. There is no that this equation for the electrochemical cell. V is equal to relationship between the potential of the cell, EMF, and the current and internal resistance. Internal resistance is a relationship. Using this equation, calculate V and V1 and V2. So this is this equation. So what is V1? V1 is equal to epsilon minus now. Epsilon 1 minus I remains same R1 for this one. Look at this equation like it. What is V2? Plus V2 minus epsilon 2 minus I R2 for this second cell. Then what is the total voltage that is between these two is equal to total EMF or effective EMF minus current into effective resistance, total resistance, internal resistance. Look at this is the equation. Write the same equation with effective resistance and effective EMF, total EMF, total resistance. Next, simplify what we get. Here take out high common factor. You get this. Here you get this. You know R1 plus R2 is in this series now. That is internal resistance or external resistance. R1 plus R2 is the RV effective resistance. This is one. Can apply the same thing here. So this R1 plus R2 is equal to RE. Therefore minus IRE minus IRE cancel. Remaining is epsilon E is equal to epsilon 1 plus epsilon 2. That is effective EMF is sum of the EMF of the two cells in series. If you connect the cells in series, we can increase what is that EMF. We can increase the electric energy. We can increase the electric, multiply the electric power in the series. That is why when they say here for a more amount of electric power, many cells are connected in series. That is why. So what is the equation for this kind of fashion, that is parallel fashion? Here same potential V between these 2 points, that is the case, same potential across this, same potential across this, both the cell. Cell EMF is this, EMF is this, and resistance is R1, R2. For this parallel fashion, then recall the same. What is I? Apply the same equation for this kind of what is that network. I1 plus I2. Calculate I1 and I2 using the equation. This is V. What is I? Rewrite the same equation. Take this left hand side, this V on the left hand side. Get epsilon minus V by R. I is equal to this. So calculate height 1. Here becomes epsilon 1 R1. V remains same. What is height 2? Epsilon 2 R2. Don't substitute for I, keep it as it is. And simplify taking LCM. Get this. Remove brackets. We get this. We get this. This is the one we get. And cross multiply, we get this. Now we will change some left hand side and right hand side. Take this term to the left hand side, this term to the right hand side. And V is equal to multiply this to both terms like this. Take this one to right hand side. Go to denominator. And this is the final equation. This is the final equation minus this is what is R1 R2 by R1 plus what is that? Effective resistance for this for the that is resistors in what is that parallel like this. This is the one. Resistors in parallel, whether it is a cell or some other resistors. Same thing you write. This is RE. So this is the one final equation. And what is the V for effective? That is effective potential, that is total potential, that is equal to is same equation. E total EMF minus I into RE. That is for the total effect. This is one already derived. This is one for total. Just compare these two equations are same. Look at this second term remains same. First term remains same. That is total is equal to. Then what is epsilon E? Epsilon E is the second term like this. So you can compare this. These two are comparing. Therefore, this must be equal to this. So this is how we can derive. I want an expression for epsilon E, effective EMF. If the cells are connected in this fashion, is equal to, look at this mathematics. Epsilon 1 R2 plus epsilon 2 R1 divided by R1 R2. Here will not multiply, additive. There is an equation says that. So effective EMF for this connection, for this type of what is that arrangement is visible. And as you know, effective resistance, internal resistance for this parallel fashion is R is equal to R1 R2 divided by R1 plus R2. So effective internal resistance of these two cells in parallel is this, and effective EMF of these two cells in parallel is this equation, this final equation. These equations are required for calculation, that is solving problems. Remember the equation. So here resistors are used. What is the effective resistance? Here the cells are used. What is the effective EMF and effective resistance for this series, for this parallel? So these are the equations derived this. So with this we have completed this subject.